Tanya says, Me'emes Maskirin al Akshamim. It doesn't say al Akshamim, it says Maskirin Gvuris Geshamim. What's the story of Gvuris Geshamim? Says the Gemara, Mipnei Sheyeldim B'Gvura. I'm going to show you the Gvura of Geshamim like you never saw before. And when you say, Mashiv Ruach Amar de Goshem, on Shmini Atzeres, you'll say it a little differently than you did before. I think, unless you've seen this before, but it's Ayim V'Nair. Says, "Vayecham mikol ha'adam." He's talking about Shlomo HaMelech. He was a very wise man. He had a achalim, and the Rebbeinu Shalom asked him what he wants. He said he wants wisdom, so he made him wise. And the pasuk says, "Vayecham mikol ha'adam." Rashi brings down the psikta, mikol ha'adam. You know how wise Shlomo HaMelech was? He was wiser than Adam Harishon. He was even wiser than Adam Harishon. Adam Harishon was not a caveman. He was a Chacham Gadol. He was a very big Chacham. And what was his Chachma? He named the animals. So the Rebbeinu Shalom says, "V'chol siach hasod eterem yeh ba'aretz, v'chol esev hasod eterem yitzmach." Ki lo himtir Hashem Elokim al haaretz ve'odam ayin la'avedas adam. We're going to read this Parshas Beraishis. It wasn't yet time to make things happen. Everything was ready to go. The whole world was created. It's ready and raring. It's happening. But there was nobody to appreciate the bracha of rain. Rashi says, Ki lo himtir v'may time lo himtir lefi she'odam ayin la'avedas adam. Nobody understood nobody was there to appreciate the taiva of the rain. When Adam Harishon came and he saw the need for rain, so this is the first recorded tefillah that I know of, the first recorded tefillah for rain, because Adam understood what was needed here. The Gemara in Tainus, Daf Tes, speaks about how rain works. Tanya, Rabbi Eliezer Reimer, Kol ha'olam kula mimei yukyonos v'shoisa. It all comes, whatever the mimei yukyonos is, maybe the Atlantic Ocean. All of the rain, all of the world is shoisa. It gets watered from the waters of the Yukionos. Shneimar ve'ed yalam in haaretz v'hishka es kol pnei adam. Rabbi Shua asks Rabbi Eliezer back, wait a second. The rain is drinkable water. The Atlantic Ocean is salty. How could you tell me that this rain comes from here? It's not salty. It becomes sweet in the clouds. It's a cleansing. This is a chiddush gadol. You should understand that the Chazal, Rabbi Eliezer is saying he understood. He's telling you all about evaporation right here in this Gemara. Rabbi Eliezer is telling you all about evaporation. We're going to talk about it. salt stays behind. Imagine that. I take a cup of water, I mix it with salt, it becomes salty like the Yam Melech, and I could separate it back out. All I need to do is let the water evaporate, and all the salt stays behind, and all the water goes into the vapor form, and it becomes water vapor in the air.
It becomes sweet.
It becomes maskin vavim. That's right. The pasuk says, "Vayikra Elokim l'rokia shamayim." Rashi brings down. This is all psukim in Pashas Beraishis. We're going to read this one. Samayim. Shamayim means samayim. It carries water. Shamayim. Over there is water. Shamayim. It's a mixture of fire and water. What's mentas? Fire and water. Says Rashi, She'ervon zeh v'zeh v'osa mehem shamayim. He mixed the fire and the water together like Makas Baruch. He made shamayim out of fire and water, two opposites. It's interesting, the Medrash brings down that Malach Michael is made of Sheleg, Malach Gabriel is made of Eish, and they stand next to each other and they say Kodesh, 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 and they don't destroy each other. L'kayim ha'shnemer, oiser shalom imreinu. I'm going to suggest that the fire is electromagnetism, one of the four fundamental forces of nature. This is perhaps even what the Ramban meant when he spoke about the Hiyuli. I have my thoughts on this, but that's for a different time. Electromagnetism is rays, it's cosmic rays that come out. Closest to us would be the sun, but from other stars as well. And it bombards everything between the sun and the earth. It's completely dark until it hits our atmosphere. All of a sudden it becomes light. And that's only one small portion of the electromagnetic spectrum. And if you look at the piyut that we say by Tfilas Geshem, it says, "Kenevak lo sar bol me'esh u'mayim." When it's talking about Yaakov Avinu, he fought with a malach that's mixed, a mixture of fire and water. I don't know. I didn't finish my Kabbalah 101 class, so I don't know what this really means. But you see that the two opposites. With this we're asking for with this chus, we're asking for the rain to fall that comes from the shamayim made of eshumayim. Now there are other places in the universe that there is precipitation. There are other places in the universe. The earth is not the only place where we have rain. But it's the only place in the world, in the universe, where it rains water. You have places like Venus. Let me explain what Venus is like. You put your chicken into an oven. It's about 350 degrees in the oven. Okay? Venus is hotter than that. Venus is more like a matzah oven. I was once a sheber. Let me tell you, it's hot. The surface of Venus is about 850 degrees Fahrenheit. It's not. It's a very dangerous temperature for anything. I'm not for anything. Now, I know there are some people that want to go to outer space and start colonies on Mars and put. I'm very happy right where I am. This is not a place out there. I'll digress for a moment because it's hard to do so. Just to the astronauts, Bisman Hazeh, that go out to outer space for a short time, come back with serious health problems. They lose about 2% of their bone density just being in outer space. You're going to take a trip with Elon Musk to Mars for a half a year, and you expect to be able to stand up out of your bed without, breaking all the bones. Why would a person do that to himself? That's a separate matter. But so anyway, Venus has a very hot surface. It is so hot that it also rains. But it doesn't rain water, it rains sulfuric acid. Sulfuric acid is so acidic, at least on Venus. It is less than 0 acidity. Anything will burn in that kind of acid. Even the Teflon that is extremely resistant will decompose in this H2SO4 sulfuric acid. It's not a normal, it's not a place to be. Another example, there are many examples, I'm just throwing out two. The places that it rains diamonds. Imagine being pelted with rocks. The mountains. But there's another place in this solar system. One of the moons of Saturn is called Titan. It also rains there too. But it's not hot, it's cold. It's a completely opposite. It is so cold, it rains methane and ethane rain. Over here it's gas, methane gas. I looked it up. It's negative 300 degrees in the Fahrenheit scale. It's measured in kelvins in the laboratories. They don't use Fahrenheit, right? I wanted to speak in words that we're more familiar with. 300 degrees below zero. There's no place on Earth that is so cold. Never was there a recorded temperature so cold. I would go on with this. I'll leave it for now. But there are other places it rains, but there is no other place in this known universe that it rains water. It's a huge, huge chiddush. The Chazal tell us in Pirkei Avos that Rabbi Yochanan Zakkai had 5 Talmidim. And the Talmidim were known. And one of his Talmidim, his prized Talmud, Rabbi Eliezer ben Horkenes. And the Mishnah in the Perek says, Hu hayamani shivcham. He went through the shvachim of every one of his 5 Talmidim. And what did he say about Rabbi Eliezer ben Horkenes? He said Rabbi Eliezer ben Horkenes was a bar sud she'enim ma'abed tipa. He retained everything, but the mashal was a tipa. And this has to be understood, first of all, why in the world is this a shvach? Why? Who cares? The guy who has a gift, he remembers everything. I was talking about this once. I said, there are people who have competitions. They have competitions memorizing the numbers of pi. Pi is an irrational number. It goes on forever. You're never going to get a perfect number because it's always going to get more fine-tuned and fine-tuned. So there are people who have competitions memorizing how many digits out past the decimal point you can remember. It's like sitting there and memorizing the Manhattan phone book. So he had a brilliant memory, and he memorized the Manhattan phone book. He wasted his life. What did he do with it? It's like, it's no different to me than the guy in the Guinness Book of World Records that ate the most hamburgers in the shortest amount of time. That was a shvach that he had a great memory. It's like on a tombstone, you say, he had a big memory. This was very tall. This one, man, was very strong. What did he do with it? That was the shvach is what you do with your thing. The fact that you have a gift from Hashem is not a memory, is not a shvach to a person. So we have to understand what Rabbi Yochanan was saying. The pshat, he was given a mashal. He said, it is a borsud she'enim ma'abed tipa. This is the land of opportunity. The Torah is nimshal tamayim. You can only learn Torah in this world. This world is doima to the inhabited area, and the next world is the Yam or the Midbar or the Shabbos. You can't accomplish anything in the next world. You can only accomplish in this world. The shvach was she'enim ma'abed tipa. He understood this message. And he nutzed us every moment, every tipa. Because this is the only place that you have a tipa. There's no such thing as a tipa elsewhere. The whole universe, you can look, there's no water. You can have ice, you can have gas, H2O in the gas form, but it doesn't melt into water. It goes directly, sublimates, it goes directly from the solid state into the gaseous state. There's no such thing as an in-between state. You're going to find maybe underneath one of the things, but not in the exposed, first of all, they haven't proven. But even if they have, it's not in the exposed universe. It's not like an ocean, water, you open up the tap, you take it for granted. It rains, power plunge. A typical rain cloud. A typical rain cloud, nothing special. It holds anywhere, depending on how big it is, anywhere between 1 million to 1 billion tons of water. Tons of water. Try to imagine taking that amount of weight of water and pumping it up to the clouds. How much energy would it take to do such a thing? How big of a motor would you need to get 1 billion tons of water to the clouds? And how much noise would it make? Think about that. How much noise would it make? It takes another different. It's complete silence. What? And it holds it there. It's also true. I was just to get it up there. You don't hear anything. It's quiet. It's only This is just a regular rain cloud. The regular kind. We have it today. Regular cloud. Nothing special. Let's talk hurricanes. Hurricanes is a whole different class. You have to understand, when I speak about hurricanes, it's like a different category. I made some cheshbonos. I'm not going to go through all the cheshbonos. But hurricanes, you see them from segments. You don't just see them from regular. You have to go up to space to see the whole hurricane, to appreciate the size of the hurricane. Hundreds of miles across. The amount of area it covers is staggering. A regular hurricane. What's a regular hurricane? I don't know what a regular hurricane is. There's different kinds of hurricanes. Whatever a regular hurricane means, it's about 100,000 square miles. We'll call that an average size hurricane. And I have all sorts of statistics about how deep it is, how much water, but I'll get to the bottom line. After the cheshbonos, and I took out a lot of the cheshbonos because it just confuses us. It takes away. It's about 1.74 trillion gallons of water. That doesn't mean anything anymore.
Per cloud?
What's that?
Per hurricane cloud?
How much water falls in it? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. It's a big number. I don't know what that means. It's huge. We're getting into Gvuras Geshonim now. This is where it starts. This is where it starts. Now we have to factor in, to get the rotation, to appreciate what it means that the hurricane rotates. We have to appreciate the Coriolis effect. I want to just be mad with this in a short way, because there's a lot to talk about here, and I don't want to spend the whole time explaining just the Coriolis effect. But here you have a globe, and just to show you, the Earth spins on its axis. You have an imaginary pole between the two ends of the Earth. A ball doesn't have ends, but you have an imaginary pole, like a skewer, stuck in, and it spins around that imaginary pole. If you want to know the direction of the spin, so you don't forget, you hold up your right hand. If you do your left hand, it's not going to work. And your thumb is the North Pole, and it spins in the direction of your fingers. That's how you can remember the direction. So it's spinning this way. Now, some people call it the Coriolis force. It's not really a force, it's an effect. Imagine you take a paper airplane, and you're standing on the equator, and you throw the paper airplane from the equator to one of the poles. So what's going to happen? Let's take, I'm going to use a table. That side can't see me, so I'll try to do it again. So here it's spinning. I have a marker. I don't know if this is going to show. I hope it shows. I'll try to do it on a. So here it's about the equator. I'm going to spin it and draw a line while it's spinning. And what happens? The line curved this way. Now let's say I draw the line towards the South Pole. It's still spinning the same direction. The line is going to curve this way. That's where the spin comes from. But I have to explain a little bit more to fully appreciate that. So it's really an effect. It's not a force. It's the effect of the Earth's rotating on its axis that you see things that appear to be turning. They're not really turning. It's just going in one direction, but the ground underneath is moving. That's what's really happening. And if you want to understand this a little bit better, talk to the car mechanic. He'll explain it to you. Or says the car mechanic. Why is the car mechanic going to be able to explain to you the side of the Coriolis effect and why it makes such a big difference in the spin of the hurricane? Did you ever make a turn with your car? Sometimes you turn right, sometimes you turn left. Let's take a right turn. You're going to come out of my driveway, you're going to turn right. When you turn right, did you ever think about this turn that you're making? You have two sets of wheels, one on your right side and one on your left side. As you turn right, you have two arcs that are created. And the inside wheel is making a smaller arc than the outside wheel. So that means the inside wheel is a smaller circle, and the outside wheel is making a larger circle. Well, how does that work then? I'm turning my car, and that means that the inside wheels are going slower than the outside wheels in order for them to keep up pace. If they didn't turn at the same pace, then one side would be dragging and one side would be going. It would be very hard to turn your car, a simple push-it turn. So how does it work? They run smooth. I never had a problem. I mean, I had problems with maybe that was the issue, I don't know. But what's the pshat? How does the Maisa, we have to understand that every time you make a turn, one side is turning faster than the other side. There's something called a differential. In your car, you have a differential. It adjusts for the two sides, and it makes it keep pace. I'm not going to go into the differential, but that's what it does. The same yisoid is when you are turning this globe. This center, the belly, the equator, is going a much longer distance. It's traveling much faster than the poles. Of somewhere, as you go up or as you go down to different latitudes, you're traveling a shorter distance. This is traveling the longest distance, this is traveling a shorter distance, this is traveling no distance at all by the pole. That's where you can start when you want to understand the Coriolis effect. But what I'm trying to bring out from this whole thing is that part of the Gvuris Geshamim is the actual rotation of the entire Earth. Did you ever consider how much force it would take you to give that a little spin? And it's been spinning fine ever since it started. You know, it's like there's a lot of kayach there. I would go on with that, but I'm not gonna. I think I'm gonna stop with this because I have more to show you on. This is a taste to give you a me'ain, a touch of what's happening when the Rebbeinu Shalom makes Geshamim. Okay. You have to factor in something very significant, and that's the combined energy of the hydrogen bonds. Every water molecule is connected to the next, every H2O within a water molecule is connected to the next one with a very weak bond. It's called a hydrogen bond. It's an attraction, like a magnet. But it's not a strong bond, it's a very weak bond. And I'm gonna explain why it has to be weak and why it's just right. It's like the story of Goldilocks. It's just right. It's not too hot, not too cold, not too this, That's like the Rambam, that tells you a person has to be noig, his days, he shouldn't be too stingy, he shouldn't be too generous. All these things have to be just right. The Rebbeinu made his whole world just like that too. Just right. The hydrogen bond, just to give you an idea of how important and how much power is in the combined hydrogen bonds of all of what goes on in a storm. A few people tried to do this. They took two big fat phone books, let's say a Manhattan phone book, okay, and they interlaced the papers. Like one here, and they took them and they laced the papers. And then they tried to pull them apart. Now, there's a friction between one paper and the next. So if you just have one paper, so I could pull this out. It's not such a big deal. I don't need to be a Shimshon HaKibrit to pull it out. But when you have a big fat phone book, you're combining a lot of papers. The friction of a lot of papers adds up. So they had two very strong people, one on one side, one on the other. They put each bonding on a clamp, and this guy pulled, and this guy, and it wouldn't come apart. So then they tried with two cars. They attached it with two cars, and each car drove in the opposite direction. And it wouldn't break. And then they tried something stronger. They tried two tanks. Two tanks. And it broke, but not where it was interlaced, because that wasn't the weakest point. In a chain, the weakest link is going to break. It was by the binding of one of them that cracked. It held. It was and I even know. This is just from something we could relate to, friction. When something like this is friction, just the right amount. These hydrogen bonds, they hold the water together. Did you ever wonder why, when it rains, you don't have Niagara Falls falling on your head to destroy every single house and tree and person and everything in its way? But why does the water fall benachas, in small drops, just right? Everything is just right. That's because the hydrogen bonds are not strong enough to contain a big droplet. It has to be a certain size. If it's too big, it'll break apart into two. That's one of the things involved. You have to appreciate the chachma, the koyach, the gvura, the wisdom. We have to factor in the power of the sun. The sun, if you ask, like, let's say AI, how much energy is in a hurricane, it'll give you an answer, something like 10 Hiroshima bombs per second. It'll tell you something like that. So you have to think about it. Think about all the water it's churning and all the... That's not everything, though. That's not everything. The thing that powers the hurricane is the warm water of the oceans. What warmed that water? You have this huge sphere in the sky called the sun. It's a star. 1.3 million Earths fit into the sun. It's all about nuclear fusion. Not even fission, it's nuclear fusion, where you have two hydrogens coming in to become a helium atom. And you have these hydrogen bombs constantly going off every moment of the sun's life. There are people who are worried it's going to power out soon. It's been working fine. I'm never going to see when they bite their nails. They don't have any nails left. They worry about a lot of things. They worry about global warming. My father told me when he was growing up, they were worried about that they're going into an ice age. So it depends, but there's more money. Right? The average that feels developed, the rest of I'm telling you, people, I feel bad for them. In fact, what to worry about. Okay? If you're a kafir, then you have a lot. Imagine that this is a small digression, forgive me. Imagine we're on a little satellite, a little dot, like a marble, compared to this huge, and we're flying around this huge ball of fire at incredible speeds. I'm talking about faster than anything you could possibly imagine. Imagine, and there's nobody in charge. There's nobody in charge. If we were too fast, we'd fly off into space. If we were too slow, we would fall into the toaster. That's a pretty scary thought. And there's nobody in charge. Taka is this word. What about you knows about if you don't put a bit of butter out. Anyway, back to what I wanted to say. So you have, from 93 million miles away, you have the power of the sun spewing out its energy into space, and one small fraction of that reaches our little planet. One small mashibu in the yam of the energy that's out there in the sun reaches our planet, and it warms up this massive amount of water. It warms it up. It warms it up very deep to about 165 feet down below. The swimming pool is 9 feet. To warm that up is a lot of energy. It costs a lot of money to warm it up. You want like a hot tub. This is just to warm it up. Just to warm. You have to you have to understand what kind of. This is where you could start seeing the power of the Gevuras Kishon. Just to warm up this amount by 1 degree Celsius, you have to understand how many gallons of water we're talking about. I have a number here. It's completely meaningless. I'll just count the zeros, okay? Okay, 32, and how many zeros after it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 zeros after the gallon. So we're talking about a lot of water, okay? It's a lot of water. It's meaningless to me, but if you're a mathematician, it means something to you. I'm a mathematician. We're talking about a lot of water. And if you put that into perspective, you have to picture taking the Great Lakes or something. The Great Lakes, look at it on a map what the Great Lakes are. You just look at the map later, you'll see what the Great Lakes are. Imagine warming the waters of the Great Lakes. That's the proportion of what we're talking about. Or imagine taking the whole state of Texas and flooding it with about 50 feet of water, okay? The whole state of Texas under 50 feet of water, and now warm that up 1 degree Celsius. It's a lot of power you got it. It would be enough to power the entire world times 200. For the whole year! For the whole year! Just one hurricane. I'm talking about one hurricane. I'm not talking about anything big. We have many hurricanes that come. It's millions of times stronger than any nuclear explosion that ever hit this planet. And I want to explain something to you. Nowadays, we have not like an atomic bomb that hit Hiroshima or Nagasaki. Nowadays, we have hydrogen bombs. A hydrogen bomb makes Hiroshima look like a firecracker. It is lo yu'min ki yasupar. It's taka a pachad if a person is a kaifa. I would be pretty scared. But Saram alei malachim ve'Hashem. The Moshe made the world. He's not going to just let some shugayim, press a button. But that's really what it is. That's what these people are all worried about. So Imagine it's like all the sunlight hitting the earth for a couple of hours. The sunlight, you don't think about it because we take it for granted every day. You go out to the beautiful sun. But a single lightning bolt is parallel in the earth. This is a sunlight for a couple of hours. Everything is in the precise measure. How big is the earth? So we have an idea about how big the earth is. I can give you figures, but you've all seen pictures about how big the earth is relative to other things. How much of that planet, let's bring the globe back. Could you press it? Thank you. So we see a planet, a lot of water, I'm going to tell you it's not so much water. So you'll say, but 70%, most of the planet is covered with water. I understand that. But the mass of the planet, the water, if I would tell you how much of the planet is of the entire Earth, if you would take the whole Earth and take out the water and make that into a bowl, it would be, let's say the Earth was the size of a basketball. And I took all of the water on this basketball and I put it into a cup. How many ounces would that cup be? So I'm going to tell you something amazing. It'd be about a third of an ounce. A third of an ounce. A third of an ounce. Better. It's a massive planet. Imagine that your kid spills water on the floor. It looks like a huge puddle. This is garnished. You have to understand. This is not so much. To us, it's a lot. But compared to the size of the planet, it's not. And this is most of the water. From that, this is all of the water. But from that water, only a very small percentage is fresh water. And most of the fresh water that's drinkable, is not salty, most of the fresh water is not accessible to us. It's locked up in ice caps and in places we can't get to. Most of the fresh water most of the fresh water is not accessible to us. Elamai, the little bit that's left.
What are you leading to? But it's enough. What's the difference? How much?
That's what I'm just trying to bring a perspective.
Question of what point? How much water we need?
Yeah, what we think and what is actually the Metzias are not necessarily, they don't stem.
You're talking about hemorrhoids, yummy.
Yes, everything. Alles.
Under the water.
Fresh water, everything.
Under the water, toiling.
Correct. All the water of the planet. All of about a third of an ounce, if the size of the earth was a basketball. Then that's not a guzman. That's about accurate. And
So what are you taking out of that?
one second. I want to show you what it means when. One second. Let me finish the thought. Only a portion of that is usable for us to drink, and only a portion of that is accessible, and a very small portion of that. So you think such a big river, the Mississippi, the whatever, any river. Try to imagine a little scratch over here, And that's the whole river. It's not a whole lot of water. I would say it's about the size, all of the fresh water that's accessible on the earth, compared to the size of a basketball, will be about the size of a grain of sand or something like that. It's tiny. So it doesn't make sense, but that's the Metzius. Now, what I want to bring out, this is the point that I'm trying to make. Everything is in the precise measure. It's like the enamel on your teeth. We know that the hardest surface in your body is the enamel on your teeth. But it's only on the place where it needs to be. And it's a very thin little covering, because that's where it's needed. I don't need it elsewhere. I don't need it on the bones. I don't need it on my fingernails. I don't need it elsewhere. I just need it in one place, because that's where I'm biting the food. The Rebbeinu Shalom makes everything with exactly the shear that you need it. You don't need more. So he gives extra, but what I'm saying is he doesn't. If you don't need, he doesn't. It's like I could give you a few mashalim, but for now I wanna try to be Messiah. So.
Gvura on the water that we have?
Gvura for the water.
Accessible fresh water that we already?
Yeah, look what Hashem does in order to make sure that it rains and everybody has. So now, the Gemara in Taina says, Afilu Omer Magar HaRuach Mafriach Hatal Ein Machzir Naiseh. You don't go back, because the Tal and the Ruach, they don't stop. There's always going to be Tal and Ruach.
What about Geshem? Why is there Geshem?
No, Geshem is not, you have to go back for that.
Let's say why.
But Tal and Ruach, I'm going to explain why. What's Pshat in Tal and Ruach? Here's a cup of water. Not very exciting. I'm going to show you something that is very remarkable. Now, I would very strongly suggest that you do this over a sink, because it doesn't always work. You know, in the laboratory or the pictures, it always works. But I'll take my chances. What's holding this water in the cup? If a butterfly would land on this, it would all fall out. Why did it stay? I didn't have any glue there. It was nothing. I guarantee you. I'm trying to trust me on that. The reason why it stayed is because of atmospheric pressure. And this is another point to understand when you're talking about the Gvura. Hashem puts everything into place. The atmosphere is very heavy. It is so heavy, you and I and everybody on this planet walking around at sea level, or about sea level, is carrying a car on their shoulders. You say, what do you mean? I say it's a car. I don't feel any weight. What are you talking about? The person's been down some sugar. There's no car on my shoulders. I don't feel I can stand up. I can sit down. I don't have any weight. There's a car on your shoulders, and to explain it, the reason why you don't feel it is because it's equally distributed all over. It's sort of, imagine going under the water, and you're now 10 feet under. There's a lot of weight on top of you, but it's pressing all over, so you don't feel the intensity that you don't. Everything is benachas, it's perfectly, but you need that pressure. You need that pressure to create the winds. You need that pressure for many, many things. And you need that pressure for the rains. I'm going to just say one more thing, and then we'll go to the last slide. There's another thing about humidity I want to explain. Could you pass me that bowl, please? Thank you. This same cup, very unremarkable. Well, it was unremarkable until I did that little thing. Now it's a remarkable cup. Now it's a magic cup. I'm going to take some ice. I'm going to put it in. And as I put it in, it gets cold. And it starts to frost over. It's a little bit full. I'm not going to put in more. But take my word for it. You can look for this. See, this was dry before. It's frosted. Why is it wet? It was dry. Why is it wet? Did you ever wonder that? You're sitting on the side, you're on your vacation in the Bahamas, and you're enjoying the weather, and you have your ice cold drink with the ice, you know, with the iced tea and all, whatever you have, and it's wet. Why is it wet? Where did the moisture come from? It was dry before.
Outside.
The answer is that the humidity, when it hits the surface of the glass, all of a sudden it condensed, and condensation, and it became a water droplet. And that's the process of the water cycle. And it's a completely recyclable system, because the same water that they drank in the Midbar, we're drinking now, because it goes around in a circle. Maybe the Bear Shimmer, I don't know. So we have to think about these things when we think about the rain. There's so much involved. You should know that there's much more about the rain, about the Gvuras Geshonim, but this is like a aim of what's involved in the Chochmah of rain, and what goes into what the Rebbeinu Shalom did in order to make it rain. In Kehelis Rabbah it says, Amar Rabbi Yanai, B'nai Sheba'olam, Adam Lekech, Litra Shel Basar, Kama Tzav, Kama Yegia, Roya Ashi, Vashlana. He prepares a piece of meat, so much effort goes into that preparation. V'ani Mashi L'chavuas, Luchas, Umale Anonim, Umayred Gshamim Utlalim. I blow the winds, I bring up the clouds, I bring down the rains, the Tal. Umegadol Tzmachim Umevashlan. I make the tzemach, the things grow. The apple, it becomes ripe on the tree. It's in mevushal, it cooks. And I set everybody's table. Everybody's table, I have it all set. And I give everybody everything they need. Every person has what they're missing. All I ask you is to bring the Omer. This is the Medrash Rabbah. This is all the Rebbeinu wants. Follow the script, do what he wants, and appreciate the gift of rain as one of the many, many brachas. But it's one of the three things that the Rebbeinu doesn't give into the hands of any shliach. Thank you for joining us. I appreciate it.